We are starting the demo video for analog and digital electronics software. For this software, we have provided a hardware lock. This is our hardware lock. This is a USB drive which serves as a lock for the software. The software will work only till the time the USB is connected to the computer. This single USB is capable of controlling two softwares. One is our digital software and another is our this analog software. So first we'll go to the digital electronic software. In this software, this is our complete setup which we are going to provide. For basic logic, we have De Morgan's law, basic logic gate, XOR gate, combinational logics, we have half adder, full adder, multiplexer, BCD, we have shift register, we have counters and sequential logics. So I'll first show you the basic logics and then we'll go to other semiconductor memories and other things. For the De Morgan's law, what we have provided in the software is we have given the theory of how De Morgan law is working, and we have provided a solution simulation. There are two ways in this simulation is working. One is continuous. As you can see, the LEDs are going high and low with respect to the inputs. Other is step by step. You can just simply press next and you can see the state changing from 10 to 11, 00, 01 and 10. To close that, we just have to press on the close and we can go to Boolean algebra. This is basically theory which we have provided for students to understand that what is the law of identity, commutative law and associative law. Similarly, we have provided semiconductor memories. This gives a basic theory of how semiconductor memories are different types like volatile, non-volatile, SRAM, DRAM, RAM and ROM. We similarly have a JK flip-flop. Here is the theory. This is our chart of a JK flip-flop with the sequence of J, K, Q and QT plus. We will go to low and continue. Now you can see here this is our clock K, J and QM. These things are all working simultaneously. You can see it all here. This is our input logic, this is our intermediate logic and this is our final logic Q and Q bar. Now we'll go to the similar type of output is in all other type of experiments. You can see the logic, digital logic representation here. You can see your graph on the left side at as per time 0, Q2, Q3, Q2 and Q1. Now we'll go to analog electronics. In analog electronics, we have semiconductor devices, register combination, op-amp, theorem, laws and amplifiers. We'll first use the Thevenin theorem. In the theorem, we have the theory, the circuit, the calculation, the formula which we are using, and we have a simulation setup of the voltage with respect to resistance. You can get the output of the various steps by changing the values from the scroll bar. I think you can clearly see RTH, Thevenin resistance, Thevenin voltage and current at load, all changing with respect to the input. Now we'll go to and open loop amplifier. This is our open loop amplifier circuit. This is V1, V2, the input, and this is our output. This is our input and output. This is the formula which is used. In every simulation, we have tried to get the most out of the system. Like this is our semiconductor. In ideal, we have 2 approximation, 3 approximation. This is our Zener diode application, germanium diode and LED. As per laws, we have Ohm's law and other laws also. Here you can change in the circuit, you can change the voltage, and you can see the representation of the output with respect to the change in voltage. Then you have your amplifiers. This is my class A amplifier with my output graph on top. So the change in resistance, you can see the change in output. Then you have your own RLC series circuit. This is our input signal, this is the output signal, and this is the circuit representation. Now, by changing the value of R, L, and C, you can see the change in output. This is the formula which is used, and this is the theory how to use it. So this is the calculated phase angle shift of the output and input. The red is the input, the green is the output. So this is our complete representation of every experiment which is given here is working, and you can change the values and check the output. This is the complete representation of analog and digital simulation software.